Alright, what's up everybody? Welcome back to the series. So today in this video of the series, what we're going to be doing is making a parser. And if you're unfamiliar with what a parser is, I'll demonstrate. So if I type in console, for instance in C#, it recognizes that I'm talking about a class, system.console. And if I put a dot and write right line, then it recognizes that I'm referring to method, and then when I write brackets, it recognizes that that's where the parameters go. And if I put squiggly brackets, then it recognizes I'm trying to type a string in. So yeah, that's what the parser is going to be. We're not going to be finishing it today because that's something that you work on throughout the entire series. That we're going to be working on throughout the entire series. It's going to be basically the backbone of our programming language. So to start off with, what we need to do is create a new class called Parser, and really in program.cs what we've made here is a very simple compiler. Like it's very simple, but what we need to be doing is it's part of the compiler and the parser. They're kind of intertwined with each other, at least in at least the way that I make my programming language. I haven't really looked at any other programming language source codes. But yeah, that's something to keep in mind when you're watching this series, because I've pretty much done this my way. I kind of doubt that anyone has done this in the exact same way. Maybe similar ways, but anyway, the first thing that we need to do is move what I've copied. We need to move all of this. I'm cutting that and we're moving it into parser.cs. And the reason we do that is because, as I said, a lot of the things in program.cs are part of the parser, so we're going to be moving it all. And we can now remove that. And another thing that we can move is this right here. And we're going to make a function called public or private void add byte. And the reason we make this function is, and this is where we're going to paste the code that I just cut. And the reason that we make this function is because every time you, I could better explain this if I show it. Alright, so this right here is the header of our application, so it doesn't matter. I'm just going to delete that for a second. But as you can see, there's one byte in our programming, in our compiled executable right now. Every time that you add a byte to this, so if I add another byte here or another one here, it doesn't matter what it is. It could be this or like this, or you know, something like that. And for every byte that you add, the memory address goes up by 1. So it's useful to put in a function add byte, and obviously you're not only going to be adding this type of byte, we're going to be adding many bytes, so we'll make the parameter byte b. And there's also other reasons this is useful, but that's like in later videos, so we won't be adding it now. But another thing that's useful is private void add bytes, and I could just do this. I could just do this, however, there's there's not only one type of lists, or there's not only one type of collections in C#. There's many, and we can select all of them by typing IEnumerable byte. So now that'll work for lists, it'll work for arrays and everything. And now for the memory address, we'll define it in parser, and the reason that we're defining it here is because the memory address is only set to this if it's a Windows application, and we will be mostly making Windows applications, so that's why I'm going to make a boolean Windows application here. I'm going to set the true by default, because we are going to be making only Windows applications. But let's say down the road we don't want to make a Windows application, we want to make like an operating system per se, just because it's a or I didn't mean to say per se, but let's say we make an operating system, for example, just because that's a very simple thing that isn't the Windows application. Then you wouldn't want to start at this memory address. You would want to start at a different memory address. You would want to start at 0. So what we'll do is we'll say if it's a Windows application, then set to this, but if it's not, then set to 0. And the next thing that we're gonna do is we're gonna create a public byte parse. And we'll take in a parameter string data. And before we do that, let me make sure that we've moved everything out of here. Alright. So, the return value of parse is going to be all of the bytes, every single byte we need to write to our executable file. So, that means that we're also going to have to compile, and we're also going to have to create a private byte array compile. And what this is going to do is, as I said earlier, we made a very simple compiler here. So what we can do is just cut out everything that we used to compile and move it into here. And this is all the compiling code we've done so far. And then we'll just return it, final bytes up to array. And then another thing we're going to do is we're going to also add a byte at the end of our application. So when we compile, that comes after parsing, and we're going to add this one byte. Now the reason this byte is important is because what this byte means is return. And there's two reasons that we add this at the end of our application. And that's because, so no matter what happens, no matter what the user writes in their source code in your programming language, no matter what they write, they won't have an empty application. So if they leave it blank, they won't have an empty application, for instance. It'll always have this one thing. And also, it's so that it will always it will always exit out of your executable eventually. Instead of like, it won't run instructions that are just randomly in memory. It'll exit your executable, because what the return call does, it either returns from a function, but if there is no function to return from, then it exits out of your application. So basically we're just adding this to exit out of the application when the code is done running, and also so that the application is not left blank, because that will if the application is left blank, then it will say this is not a valid Windows 32 application. And now what we have to do is start working on the parser. And the way the parser kind of works is there's something called parsing status that we have to add. And it's an enum, so we'll go ahead and add the class to our project. public enum parsing status. And what parsing status is, what it's going to be, is it's going to tell you, well, it's pretty self-explanatory. It's going to be the current status in parsing. But it'd be best if I gave you an example. Or not an example, if I just told you what exactly we're going to be writing in here. And the first thing, and this is going to be what the status is going to start off with. And it's going to be searching name. And the other thing in parsing status is going to be reading name. So, of course, you can tell that these are going to be the only two statuses we're going to have to start off with. And the reason I've chosen the word name is because if you in just C#, for instance, if you put in an invalid statement like this, and first I'll fix the other errors. So the error here is that has to be uint32 0, and then I'll fix that later. But the reason that I chose the word name in parsing status, searching name, reading name, is because, as you can see down here in the errors, it says the name T does not exist in the current context. And as you can see, it's just called name there. And then there's a other error, but we'll be focusing more on that later. So the reason that's why I call it name. There's really no other reason. In my other programming language, I called it keyword, but that didn't really make sense, so I decided to change it now. I like name a lot better. And yeah, that's just the only reason I chose name. Now the other error here. Oh yeah. Return compile. So you want to return the compiled bytes. And the other error is that final bytes.toArray does not exist anymore. So we have to actually make the parser in program.cs. And then we have to actually parse. So as I said, this will return all of the bytes we need to write to the file. So when we're writing all the bytes to the file, instead of writing final bytes.toArray, we'll just write parser.parse, because as I said, it returns all the bytes. And it's also going to give me another error here, asking me for an argument. And I didn't exactly explain this argument right here. What the string data is, it's the source code to your application. So for instance, or I'll just show you the exact example. What we're going to be doing is having a source file, source.txt for now. And in this, say you have some source code to your application, like if int I equals 0. This probably won't be how source code looks like, but I'm just saying. This is what data will contain. It will contain the source code of our programming language code. And to get that, what we have to do is file.readAllText, and we'll create another constant string, source file name, source.txt. And because that's what I named it, source.txt, and you can go ahead and write and create your source.txt file. And we will change it from a constant later, so you could compile like whatever document you want, whatever file you want. But for now, we don't really need to do that since we're just creating our programming language. But yeah. So now we'll go back to the parser and start actually creating the parser code. So one thing we're going to need to do is set the status, and we'll put the status actually up here. Whoops. we'll just call it status. And whenever you parse, it'll be on by default just searching for names, for the name, because it won't be reading it, because it has to find it first. So we set to searching first, and the next thing we're gonna do is import using system.text. So the way that we're gonna parse this, the way that we're gonna parse our source code, is we're gonna go through every single character in the source code. And the way we do that is to loop through every character in the source code is easy using a for each statement, and loop through every single character in data. And the reason that, or one thing about parsing that text data like this is it's very easy to learn and figure out on your own. This was one of the first things I was able to kind of figure out and do by myself. It was kind of like I got good at parsing text by myself, and you know, it may not seem that significant, but it kind of is when you're like parsing HTML and stuff. But yeah, I really recommend that. Maybe like if you feel confident enough to kind of make your own syntax, make your own, you know, parse the code in a way that you like the best, that looks the best. Because I feel like when you're making a programming language, one of the main things is that you know, you have like a unique way that your code looks like. So this is kind of your opportunity to do that. But nonetheless, I'll move on to this. But for every character in your code, it's going to do something. It's going to compile. It's going to parse differently depending on what the parsing status is. So we're going to switch the status, and right now we only have two different cases, which is parsing status dot searching name and parsing status dot reading name. And since those are our only cases right now, we don't even have to do defaults because that doesn't exist. As you can see, it doesn't exist. And I don't even think you can set it to null, can you? I really don't think you can. Yeah, you can't set it to null. So there's no other possible case. So we don't need a default statement. And what we need to do when we're searching for the name is what we're gonna do, for at least for the starting off, we're gonna check if for every single character in our code. So like, let's say our code is something like this. It's a really weird example, but you know, it's going to have to, it's looping through all these characters, so it's going to search this one right here, for instance, and it's going to check all this. It's going to check the status, and then it's going to be on searching name. And obviously, we're not reading a name right now, it's just blank white space. So what we have to do is skip it if it's white space, and there will be other skip conditions later. For example, if it's commented code like this, or like this is the more new kind of commenting, it'll skip these comments and whatnot. Or maybe we'll even have a different status for reading comments. But for now, the only thing we're gonna we're only gonna need to skip over white space. So the easiest way to do it is to create a function that returns a boolean that checks if a specific character is a form blank space, and it's easy to check because they're really only these forms of blank spaces: actual spaces, new lines, return, and this is basically only used on some systems with new line. What if you're unfamiliar with what return does, is it returns the thing back to, it returns the text editor back to x equals 0. So it's basically white space. And the last thing are tabs, and that's obvious why that's white space. And new lines aren't really blank space, white space, whatever, but they can be skipped over because they don't matter. We don't run any. We don't use new lines. Like it'd be weird if one of our keywords were like this, and this was a keyword, like it has the new line included. But I mean, if that's your thing, then you could easily make the loop accommodate that, but it just looks weird to me. So I won't be making anything like that. But nonetheless, we'll now use that function if this dot is form blank space, and then we'll plug in the character that we're currently looping. And we're gonna check if it's actually not a form blank space, because that's the only thing. That's that's when we actually want it to do something. If it's just searching the name and it is a form blank space, then break and just go to the next loop. That's what we want. So what we're gonna do is create a string builder, and the string builder is gonna be called name reader because it's gonna be reading names. And the first thing we'll do is, since we're starting to read a name, we have to append the current character to it, and then we have to change the status to reading name, and then it'll start reading name. And now we can move over to reading name, and we say if car dot is letter or digit C. So we're checking if the character is a letter or digit. And if it is, then append it to the name. Now the reason that we can't use is form blank space anymore is because, say we have this, and I know this is C#, but just say this is our code. As you can see, we wanted to stop reading the name. It would actually stop reading the name here, but like, say it's just right line. The name is right line. We wanted to stop reading the name at this bracket because now that's no longer part of the name. That's now part of the parameters. So we just check if it's a character or a digit, and the reason we check if it's for a digit is because variables can actually have numbers in them. In C# they can as well, I believe. Yeah, they can. But yeah, that's why we're checking for digits. But if it's not a character or digit, that means that we want it to stop reading the name, and that means that the name is red, because that either means that it reached the parameters, or it reached more white space, and the name is red. And when the name is red, which is in this else statement, we're going to want to create a variable to process the name that was red and see what we want to do with it. So for now, we'll just create that as a private void check name, and then obviously we're plugging in name. And just for debugging purposes, also right line got name and right now I would say is a pretty good point to check how our code is working. Well, actually, wait, I forgot to fill this in. We have to fill in this. We actually have to plug in the variable we made, or we have to plug in the method that we made, and we have to convert the string builder to a string that gets its value that it built up. As you can see, every time we append, we're adding a character to it, and then we clear it so that it could be used the next time when we need to read a name without having the old data in it. And the reason we use string builder is because when you're adding to a string in a loop, that's the quickest. Albeit we're not adding very long strings together, but still adding strings together. And now the way that we debug our code is, first of all, you compile it. However you compile it in whatever IDE you're using, it should be very basic. If you can't figure it out, then just debug it. That automatically compiles it. But you might have this at the end of your code because I added it earlier, or you might have a while true loop or something. But just get rid of anything so that whenever you run your application, it immediately exits out. And the reason we're gonna do that is because from now on, whenever we want to debug our application, we'll do it in command prompt. So if you open command prompt, and I'm sure you know how to, but just in case someone's new to Windows or something. I'm on Windows 7, so this isn't even a good explanation, but go to your Windows icon and then just search CMD, and then it should come up. But once you've done that, now go to the your project, and there should be a lot of ways to do this. On Sharp Develop, I can right click the my project and click open output folder or open folder in Explorer, and it'll take me to it. But if you can't, just go to your documents, and then maybe it'll be under Visual Studio Projects or something. I'm sure that at least a large majority of you will know how to get to your project, and if you can't, then we'll Google it because it'll be useful later. And in File Explorer, Google how to find my project in File Explorer in Visual Studio or whatever you're using. And then once you're in your project, open it up, go to bin, debug, and then go ahead and copy the path to it. And then in cmd.exe, type cd space, and then paste it in. And then now you'll be in the directory of your I'm in this directory right here in command prompt. I'm in there in command prompt. And what I could now do is I could type in the name of my exe right here, which is programming language. And it will run the application. But right now it doesn't even say anything because, as you can see, my source is empty, so I could do test name, for instance. And I'm sorry for the interruption in the tutorial, but there was a small issue. So for a moment my thing wasn't working for me because basically just append this to your code. This is a fix that I used in my old programming language. All it does is it adds a space to the end of the code because it didn't know where to stop because the data ends right there. So if you just add a space, it'll fix that. But anyway, the next thing that we have to do is on check name, we have to return the status back to searching for name because we finished reading the name. So now we have to do is go back to searching name, and then remember that every time you finish writing code, you compile it, and then yeah, as you can see, it says got name test name, and that's what I put in my code. And hadn't I put in this fix right here, it wouldn't have said anything unless I put an enter here. And then as you can see, now it gets it. So hopefully that'll help you understand why we need to put in data plus equals a space. It's the equivalent to this if you can't figure out why there's single quotation marks. But nonetheless, as you can see, I can get in any kind of string, even on the same line, or that'd be better if I didn't do scribbles, but even names on the same line. It'll detect all of them, as you can see. Name, I went through name 0 through 6, name 0, name 1, name 2, 3, 4, 5, 6. And And now the only thing that we have to change now is we have to actually make it do something whenever there's a name. And we won't be doing anything advanced today, but we'll be doing it on the next video, because this video is kind of already a little bit short on time. But for the starters, the first thing that we're going to be adding that actually does something in our programming language, the first names that are actually going to do something, are keywords. So we'll right click on our project and add a new folder and name it keywords. And the first thing we're going to do is create a keyword, and this is just going to be the base class that all keywords are made out of. And the first things that we're going to add in it is a public read-only string name, and then a public read-only boolean has parameters. Now the reason that we have a boolean has parameters is because, for instance, I'm running C# code here, but say that. So a name like this that has no parameters in here, as you can see, these brackets are empty. That means it has no parameters. So this would be false in this case. And then if there were parameters in here, for example a string, then it would be true. Or if that's if it expects parameters, would be the better way to word that. But anyway, I'll even change it to that. Expects parameters. And so yeah, that's it. The better way to explain it then would be as if it expects you to put something inside these brackets, or if it expects it to be left blank. And for the default, we'll make it required that you put a name in for your keyword, obviously. And then boolean has parameters will be by default false, because for now we're gonna make ones that are false, just for this video specifically. And then we'll just update the class. We'll just update the class variables now. And the final thing that you want in your keyword is you want to actually do something. So public virtual, and the reason we do virtual is because when you do virtual, that means it's meant to be overridden. Void execute. However, we are going to want it to return two things, and the things we are going to want to return are the opcodes or bytes to add to the file, because as I said, I want it to actually be doing things, so it has to add bytes to the file to actually do something. And the other thing that it's going to need to return is the parsing status. So one way I could do it is I could make a tuple out of parsing status and the bytes that I want to add to the file. However, it would be a lot easier. It would be a lot better to do something called keyword result, and this will just be a struct with two data types in it, with two variables in it. Parsing status, new status, public, and public byte array, new opcodes. And now we can update this to parsing status, and now it looks a lot cleaner. And we'll just, because it's gonna require me to return something here, even though it will never be used. I had these typed differently, but anyway, the reason that where was it? Oh yeah, it's going to expect me to return something even though it'll never be used. So what I have to do is just I'll return new status to the most default kind of parsing status, because you can't make it null, and I wouldn't do it anyway. It'd be searching a name, and then the new opcodes, it will just be an empty byte array, and the way we do that is just by doing that. I didn't mean to name that parsing status. But anyway, once we're done with this, what we have to do now is actually make. There's two things we have to do, and we have to make a actual keyword, and the first keyword we're going to be make is called byte. And whenever we make a keyword, we have to make it inherit the old keyword. And the way we do that is we go up to beside class, and the reason I named it KW byte is that just stands for keyword. And whenever that we want to make it inherit a keyword, is we put a colon here and we put keyword, and now this class becomes a type of a keyword, and it's going to expect a constructor, public keyword byte base, and this is where we're able to put in the name, and if it expects parameters, but we can leave that blank since I gave it a default value. So the name will just be byte. And if you couldn't figure out already what this class is going to do, what this keyword is going to do, we're going to be able to, just like in C#, we're going to be able to create bytes. For starters, because it's a very simple type of variable, at least in terms of, it's a very simple type of variable in any terms, actually. And the other thing that, this is going to compile, but the other thing we have to actually add here is public override, and then it'll, I don't think you might be able to see it, but yeah, I think you can see it. It'll let me enter and execute, because I made it virtual, so it expects it to be overridden. And for now, what I'm gonna do is return new keyword result, and the new status is still gonna be parsing status to searching name, because we have no reason to change the status, and if we did, then we don't have a status to change it to, apart from reading name, which wouldn't make sense in, I don't think, any situation. But for the new opcodes, for now, I don't really want to make it do anything useful. I just want to make it do something. So I'm gonna just return an opcode 0xcc. In this opcode, and what I did, I created a new byte array that just contains 1 byte, and that byte is an opcode. And this opcode, for those of you who know assembly, it's this opcode. And for those of you who don't, it doesn't do anything. The only reason I'm even putting it is just that we know that it's working. So you don't really have to worry about it that much. Just know that it's a byte that we're writing to the file, and it's an opcode. Now the final thing we have to put in our keywords keywords folder is the manager. So keyword manager.cs. Now what this is going to do is just going to store all of our keywords. So we'll store them in a list. And in the constructor, that's where keywords is new list keyword, and we can actually add the keywords in right through here. And obviously we only have one keyword, which is keyword byte. So just have that like that for now. And we also, since this is private, this class is literally useless because we can't get the keywords. So what we have to do is say public keyword array get keywords, return keywords to array. And the reason that I make it return an array is just so that it dereferences this list, so this list can't be modified. And there's nothing but the keywords that can be modified. So there's no, if I make it an array, then it can't be modified. Now we have to go ahead and update our parser now with the keyword things. So to start off with, we have to create a private read-only keyword manager. to start off with, we have to import, type in the using the name of your project dot keywords, and it should come up, or whatever you name the folder to. I don't expect you guys to copy me word for word if you don't want to, because this is your programming language. You should do things how you want to. But anyway, like if you, I mean, I would also recommend copying me word for word and then going back through it and doing it your own way once you understand it. But anyway, we're creating an instance of the keyword manager, and in our constructor, that's where we'll define it. Keyword manager is new keyword manager. Keyword manager is a new keyword manager, and then we actually have to use the keyword manager. So what we do, we're gonna have to use it in check name, because whenever we get a name in, as you can see, this is where we get a name. That's when we check if it's a keyword That's when we check if it's a keyword, and later we'll be checking if it's other things too. For example, we'd have to check if it's like if it's a bracket or something to end a block. That's what this is called. If I ever say block later on, and it's referring to the thing in between these squiggly brackets, that's a block. But where was I? What you have to do now is go ahead and create a for each loop, and we'll get rid of this because we'll be updating it through this now. Updating the status through that now. But what we're gonna do is create a for each loop and loop through every single keyword in this keyword manager get keywords. Except I did lie about that, because go ahead and import system.link, because we're only gonna be looping through the keywords where that don't expect parameters. And if the keyword.name, we're looping through every single keyword, right? And if the name is equal to the name that we're checking for, then we have a match. And if we have a match, get the result, execute the keyword, because that's the keyword that we typed in. It means that's the, if I type in byte, then this will run. It'll loop through every single keyword. We only have one right now. It's going to check if this is equal to this, which it is, and then it's going to execute it. And we'll type this status is equal to the new status, and we'll do this to add bytes as a new opcodes, because we can't update it. We can't update it directly from the keyword. We have to update it from the parser. And then we'll return. And the reason we're returning is because whenever you find a match, you need to return it. Because what we're going to do is create a new form of exception up here. Parsing error. And this is going to inherit exception. I went into my project and I created a new class. That's what I did there. A new item. And make it inherit exception. Now, the reason that we're making it inherit exception is because it is an exception. And exceptions are those errors that get thrown, like Stack Overflow exception, arithmetic overflow exception, IO exception, those kind of things. We're making one of those right now. And this is going to be whenever the user messes up their thing. So we only have one keyword right now called byte. So if they type in something like this, then it's going to throw a parsing error. That's the point of this. And it's going to ask for a message. And then we're going to just pass it through into the base. And that should compile. It does. And now we go back to parser. And basically, if it never finds a match, and we know it wasn't, because if it does, it would return, and this would never run. Then throw a new parsing error. Unexpected name is all. It's not a lot of data, but it's all I'm going to give right now. And then we're going to give them the name. That's all the data we really need. Especially for debugging right now. But the thing is, if I do this, it's not gonna be. We never handle it anywhere. We never handle this exception. We just throw it, and you want to really handle all of your exceptions. I say that and I don't do it, but well, that's mostly because like I don't really put many of my things out to the public, but we have to handle it. The only place that this can ever be thrown in right now, as you can see, the only place we call it is from here, which is parse, and the only place we ever call parse from is right here. So that means that we need to handle it. The only place we need to handle it is right here. So we'll go ahead and throw it in a try loop, and we'll say catch parsing or EX, and we'll say if the user is debugging, then we'll give them a detailed description of the error. However, if they're not, then we'll say there was an error in your code, and give them a more user-friendly message that gives them all the data they need nonetheless. This will give them the lines, the like every single reference to the error and everything, but this will just tell them what the error is. The other error that can happen with this, as you can see, we're messing with files right now. So if this file doesn't exist, we're going to want to handle that as well. Debug, and as per usual, if we're debugging, don't get the ugly with them. But if we're not, then we'll give them a nice message. I forgot to put EX right here. And if it's none of these, then I don't really know. Then that means we probably messed something up. So, we'll just write that means that we messed something up with our programming language. So, unexpected exception, EX two string. All right. So we'll go ahead and compile this. Make sure you compile it, and I guess we'll start seeing what happens if we do that. And as you can see, error compiling, unexpected name, this thing. But as you can see, it does get both the names. And if I put them on the same line, it does get all the names. And as you can see, if I just do one byte, what you'll notice is right here, and this is where the opcodes start. Halfway through is where they start, because this up here is the header. I hate the header personally. It's this is where the opcodes start. And if you remember, in keyword byte, 0xcc is what will be added every time we write byte. And yeah, as you can see, it gets added right there. And for every time we write byte, let's say I write it 9 times. Then that means it should come up 9 times. 9 times. And furthermore, there's C3. And if you remember what C3 is, we added it right here. It's return. And if oh shit, I want to go through my downloads. Oh, I have it right here. Alright, this is the correct one. So if I go through and open the exe on OllyDBG, I'll just show what I'm doing so there's no confusion. If I take the exe that I compiled right here, this is the compiled exe. This is the result that running this creates, and we run it. As you can see, there is a CC opcode for every single time. The byte is written, which is 9 times. And then at the end, there's the return thing. And I'll even demonstrate. This will actually work. It'll work. 3, 4, 5, 6, 7, 8, 9, and then this will return out of the application. Now we're in system code, and it'll do whatever. Now it's done. Process terminated. Exit code. As you can see down here, process terminated. And one thing more to notice is that if you remember, we were keeping track of the memory address. Right here, as you can see, the memory address ends at 401.009 or 401.00A. You can see where my mouse is. Let's go ahead and check what the memory address is at the end of compiling. We're not setting the memory address with this value, but we're just keeping track of it because it's important for a lot of things down the road. And by down the road, I mean probably next video. But before we're done compiling, I'll go ahead and write console right now, because this right here is probably the last. I think this is the last line we get before it exits out the parser completely. And you don't have to write this, but I'm just showing it to demonstrate. We'll just write the memory address of toString X, and the reason that I'm putting X right there, that represents a that makes it represent the hexadecimal value. And this right here is in hexadecimal value, as all of these things are in here, hexadecimal. And I'll compile this and run this. And as there was an error because I'm in it in only DBG, but as you can see, the memory address that is written right here, 4001000A, there are 2 zeros at the start here, but that's just because that's just because there can be, quite literally. It just fills up the number, which is 4 bytes. But anyway, as you can see, 40100A. 4001000A. So yeah. And yeah, that's going to be the video for today, guys. Hopefully you can see that where this is going. This is going slowly but surely, I guess, but it should pick up soon. It's been picking up. And yeah, I'll see you guys in the next video, hopefully.